Hello, in this video I will explain how to change the scale of your fluid simulation in Obi Fluid. There's two different ways to do this. Change the resolution of the fluid or change the solver scale. Let's do the first one. Suppose we want to reproduce the faucet and bucket sample scene at 1/10 of the original size. We don't want to change the scale of the solver, as that would be the second method. So the first thing we are going to do is change the scale of all individual objects involved in the simulation. The faucet, the bucket, also reduce the emitter radius. Fluid resolution is a parameter of the fluid blueprint that controls the amount of particles per volume unit. In 2D, a resolution of 1 will size particles so that 100 particles fit in a 1 square meter grid. In 3D, the same resolution would fit 1000 particles in a 1 cubic meter grid. Here, we see the original fluid blueprint has a resolution of 2. And the 3D particle size we get with this resolution is 0.079. We want particles to be 10 times smaller, and their size grows or shrinks proportional to the resolution value, so we need a resolution of 2000. As you can see, this gives us a particle size of 0.0079, 10 times smaller. The reason we need to use the resolution parameter instead of specifying the particle size directly is that the resolution not only controls the size of the particles, but also masses, smoothing lengths, viscosity and surface tension forces, to ensure the overall fluid behavior stays the same regardless of the resolution we choose. Here you can see the exact same simulation taking place at different fluid resolutions. We didn't need to individually adjust all parameters. Changing the resolution was enough. Okay, so now we change the size of all objects and the fluid resolution, so we can click play and see what happens. Looks more or less okay, but particles come out of the faucet very quickly. This is because we did not scale the emission velocity accordingly, so the particles, that are much smaller now, move very fast relative to their size and are getting caught up inside the very thin bucket. Also, if we try to move the bucket around, we will see that particles fall right off. This is a common issue in all physics engines that is called tunneling. You can learn more about tunneling in the video linked in the description. So, we could adjust emitter speed and gravity to account for the new particle size. Looks better, but particles take more time to come out of the faucet and things look a bit floaty due to the reduced gravity. Also, we still have trouble with tunneling because the bucket walls are extremely thin. So, changing fluid resolution will make your particles smaller, but all other things in the simulation will also need to have their sizes, forces, velocities adjusted to fit the new size. Is there an easier way to resize everything at once? Well, yes, the second method we talked about in the beginning, changing solver scale. Here we have the original scene. For convenience, you can drag the bucket inside of the solver hierarchy so that it scales with it too. Now simply select the solver and change its scale to 0.1. Let's take the camera closer to it and hit play. Now we have the exact same behavior we had, but 10 times smaller. No need to adjust fluid resolution, emission speed, emitter radius, or any other parameter. If we want to render the fluid surface, we need to use the Obi Fluid renderer component in our camera and disable particle rendering. Note that the renderer's parameters are expressed in world space, so if you change the size of your fluid using either method, you will need to adjust the renderer parameters accordingly. This is all for this video. See you in the next one.